algebra, we are moving on to PO54. CO53, we looked at the different characteristics of a parabola, and you got to sketch a couple parabolas based only on the vertex and whether that vertex was a minimum or a maximum. Today, we're going to go much, much, much deeper, and we're going to accurately graph parabolas. Okay? Now, because parabolas are not lines, what don't parabolas have? Because they're not a linear function, they're not lines, what don't they have? Nathan, thanks for raising your hand.
A slope.
A slope, okay? So whereas in slope-intercept form, all we had to do was plot the y-intercept and use the slope to find as many points as we wanted to. A little bit different beast with a parabola, okay? There are actually 3 points that you're going to need to find to graph a parabola. The y-intercept, that's familiar. The vertex, that's familiar. And then what's called reflection point. Because one characteristic of a parabola is that they are what? Symmetrical. Okay? So the reflection point is what kind of makes it symmetrical. And we'll go through all those very shortly after Sam asks his very important question.
Are we going to have homework?
Yes, you will have homework.
Are we going to have to? Oh, Chase, you're back.
So,
hi, Mr. Schultz.
Nope, no one's going to the bathroom. You're sitting here for this.
Is this a 2-day?
Maybe even a 3-day. This is a big one here. Okay? But how often you annoy me and make me stop teaching and tell you to be quiet only adds to my my motivation to assign lots and lots and lots of homework. Yes.
You know what PL comes after this?
55. So to graph a parabola, which is an ax squared plus bx plus c form, you need to find these 3 points. Again, the y-intercept, the vertex, and the parabola. Okay. The vertex is probably the hardest. It involves the most calculation. And the vertex, of course, being an ordered pair, it's got an x value and a y value. Okay? To find the x value, you're using the formula negative b over 2 times a. Okay? The x value of the vertex comes from the formula negative b over 2 times a. Now, what are b and a? B and a are the variables in that standard form for a parabola. B is your coefficient to your x term. A is your coefficient to your x squared term. So when we factored back in PO52 and we used these, right, you multiplied A and C together, did that whole thing. A, B, and C are in the same position here, which is at least helpful. All right? Once you find x, once you know the x value of the vertex, how would you find y? Once you know the x value of the vertex, and the vertex is an ordered pair, when you find the x value, how would you find y? Colin. Right. To find y, you plug x into the equation, and you solve for y. So finding the vertex is the most calculatory step. It is the hardest, and it involves that formula, and then plugging it back into the equation, making sure you're doing correct order of operations, all that sort of stuff there. The y-intercept, that's an easy one. Just like in slope-intercept form, the y-intercept is the 0b term, that constant. In a parabola, it's the c term. Okay, 0c. 0c. And who remembers why, or who can explain why that makes sense? That the x value of the y-intercept is 0 and the y value is whatever c is. Why does that match up with what we know about y-intercepts and ordered pairs? And Nathan?
In the equation, does b always have to be positive?
That didn't answer my question. Paul?
In the original slope-intercept form, for that first question down there, it's 4x minus 3, and that 3 would be the y-intercept.
Okay, but why? Mathematically, why? You're absolutely right, but why? Kaylin?
Because, what the y-intercept is a point on the y-intercept, and for that to happen, x needs to equal 0.
Yes! Remember what the y-intercept is. It's a point on the y-axis. In order for that to happen, x must be 0. And if we plug in 0 for x, what happens to ax squared?
0.
Gone, right? Because anything times 0 is 0. What happens to b times x if x is 0? Gone. We're left with y equals c, right? So the y-intercept, when x is 0, it's whatever that c value is. Nathan, now you can ask your question. Yes.
It does in the equation does B have to be positive or can it be negative?
Like in the equation that you graph, like down here.
Is it possible for B to be negative?
Yes, it is.
So what would you do if you're
Well, what's a negative value? Becomes positive. Okay. The reflection point is the point equidistant from the vertex, equidistant from the axis of symmetry, I should say, be more correct. Equidistant from the axis of symmetry, horizontal to the y-axis, or the y-intercept. The reflection point is the point that is equidistant from the axis of symmetry. Remember that imaginary vertical line going through the vertex, horizontal to the y-intercept. That's kind of a doozy of a definition. It's basically the point that makes the parabola symmetrical. I think it'll be much easier to see when we actually do it than the definition lends itself to. Okay? But the point that is equidistant from the axis of symmetry, horizontal to the y-intercept. Are we ready to graph a couple?
Yep.
Of course we are. Of course we are. Here we go. I'm going to blow this up so that I can make my parabola as accurate as possible here. Okay.
Alright, here we go, Schultz. First down.
So, this first one, y equals 2x squared plus 4x plus 3. In our standard form for a parabola, y equals ax squared plus bx plus c. You might want to write that above there just to help you remember what is a, what is b, what is c. And just by looking at the equation, we can determine a couple things. We can determine the y-intercept, which is 0, negative 3, right? It's that c value there. And we can also determine which direction the parabola opens just by looking at the equation. And we haven't talked about this yet, but the direction the parabola opens depends on the sign of the a term. Okay? The direction the parabola opens is the sign of the a term. So our a term is a positive 2. Our parabola is going to open up. Okay? Open up. And that's a nice way to check yourself to see if you've graphed it correctly. If you're done graphing a parabola and it opens downward, but you look at the a term and it's positive, so you know it opens up, it's not just, oh, I found the one exception to the rule. No, there are no exceptions to the rule. Okay? If a is positive, it will open up. If a is negative, it will open down every single time. All right? Every single time. A nice way to quickly check that. Yeah?
Can a parabola go sideways?
It's not called a parabola. And I forgot to look at what it's called. It's still not coming to me. But no, a parabola will either open up or it will open down. Yes?
So is vertex -1?
I don't know. Let's figure it out. Okay? So for the vertex, remember, we're looking for, and this is the part that's the most work here. For the vertex, we're looking for an ordered pair. And to find that x value, we're using the formula negative b over 2a. Negative b over 2a. So we're taking our values from our equation and we're plugging them into this formula here. Our b value is 4, so we get negative 4. Our a value is positive 2, and so our denominator is 2 times 2.
Oh, yeah.
Okay? Everyone see how I got those numbers in those places?
Yes, sir.
So we simplify this. We get negative 4 for our numerator, positive 4 for our denominator, and negative 4 divided by 4 when you simplify it is negative 1.
Good job, Professor.
Okay? So the x value of our vertex is negative 1. Now, when you go to plug this into your calculator, you must be very, very careful of order of operations. Tell me what is wrong if I enter this into my calculator as follows. So I want to find the y value, right? And I'm going to plug this in for x in the equation to solve for y. If I go like this, and I go 2 times -1 squared plus 4 times -1 minus 3, why am I going to get the wrong answer? What's that? What's wrong with how I squared -1?
It'll square.
Oh, it's not being parentheses, right?
Yes. Remember, when you square a negative value, you must have parentheses because your calculator treats something like this differently than this, right? Your calculator says, oh, you want me to square 1? Okay. And then that becomes negative? Okay. That negative sign is not part of the base here. Whereas when it's in parentheses, now it becomes part of the base. It's -1 times -1, which is +1. And that's the correct way to do it. Okay? I always personally, and this is a personal preference, whenever I square anything, positive, negative, whatever, I always put it in parentheses. That way, I don't have to think, do I need parentheses here or not? If I always use them, I never have to think about it. Okay? So it might behoove you to do the same, be like Schultz, and always put something, when you square it, in parentheses. That way you don't have to worry about, do I need it or not? Okay? So this is how you should enter it into your calculator. 2 times -1 in parentheses squared plus 4 times -1, not squared that time, right? It's only squared first one, minus 3. And again, it's only x that is squared here, right? You wouldn't multiply 2 times x first and then square it. Order of operations says exponents, then you multiply by 2. Okay? Everyone do this to make sure you can do it. What do you get for your y value of the vertex here? Andrea, question or answer? Maybe put the book away and then you can hear everything that I'm saying. That might help. Jocelyn. -5. Do I have a second on that?
Yes.
-5?
Yay.
-5?
Yeah.
-5?
Yeah.
-5? Okay. All right. So we're going to start to plot here. Okay. Our y-intercept is 0, -3. We're going to put that point in. Our vertex is -1, -5. So that's going to be right here. Okay. And what we've just done is we've graphed half of our parabola, right? We know the vertex is in the middle. And so it's going to start here and come up like this. Okay? That's only half of it. We know the other half has to be symmetrical. So this is where the axis of symmetry, the reflection point, comes into play here. Remember, the definition was a point that is equidistant from the axis of symmetry, horizontal to the y-intercept. So if we draw in our axis of symmetry here, which is that vertical line going through the vertex, look at our y-intercept point. How far is that from the axis of symmetry?
1.
1. So how far are we going to go on the other side?
2.
1.
1.
Oh, on the other side of the line. I thought you meant from that.
Whoop, that's wrong color.
From the Y.
1. And now we have the other half of our parabola, and it is symmetrical. Okay? Again, that reflection point, once you see it, it might not grasp it yet, but once you see it, it's a little bit easier to get than that doozy of a definition. So, what is that location? What's the order paired?
1.
-2, -3.
-2, -3 is the location of the reflection point. Okay. Tim,
Can you show me how to do how do you get the -1?
our work is here. We use that formula -b over 2a.
Oh, that's
Okay. Our b value is 4, so in our formula it's a -4, divided by 2 times a, which is +2. Right? That gives us -4 divided by 4, which simplifies to be -1. Other questions?
Can we do the next one?
Aren't these fun? You want to do more?
Yeah.
Wait.
Yeah.
Wait.
Oh.
You go over how you do this one more time.
So the reflection point, okay?
This one's a smiley.
Again, the definition is the reflection point is equidistant from the axis of symmetry, horizontal to the y-intercept. Basically what that's saying is that once you've got the vertex and the y-intercept, you've got half the parabola.
Okay.
We want to make the other half. And we know it's got to be symmetrical. So our axis of symmetry, which I've drawn in here, this is kind of like our symmetry line, okay? If you were to fold the parabola in half at the axis of symmetry, it would fold right over on to itself. So we look at our y-intercept, and we look at how far away from the axis of symmetry it is. It's 1 over. So on the other side, we're going to go 1 over, so that this is the same distance, and now we have the other half of our parabola.
That's it.
That's it. And then we just wrote down what order pair that was. That order pair is -2, -3.
Oh, okay, that makes sense.
Okay. All right. Questions on this one?
Let's do another one.
Next one. All right. What direction
Oh, I know this one.
is this parabola going to open? Charlotte. And how do you know that?
Because
The A term is negative, right? The direction is the A term, the sign of the A term, it's negative, so we know this parabola is going to open downward. What is the y-intercept here? What is the y-intercept? Jocelyn?
0, -5.
0, -5, that C value. So we're going to plot -5. There we have it. That's our y-intercept. And now we get to do the fun part, the vertex. All right. That vertex, -b over 2a. I'll put it over here this time. The vertex, it's an xy ordered pair. To get that x value, we're using -b over 2 times a. What's our b value? 12. So in the formula, it's going to be a -12. And what's our a term? -3. So we have -12 over 2 times -3. Nathan?
2.
Which gives us -12 over -6. Right? 2 times -3 is -6. And then that gives us +2. Now, you've got to be careful with calculators here. If you go to your calculator and you type this in, because you don't feel like doing 2 times -3 in your head and you want to go into a calculator instead, and you type in -12 divided by 2 times -3,
It'll be 12 divided by 2.
Then it will multiply that by -3.
you're going to get the wrong answer.
So you put parentheses around 2 and -3.
Because, again, of order of operations. If you're going to do it this way, I heard some people mumbling over here, what do you need?
Parentheses.
Where?
Oh,
Between the 2 and the
It's
-3.
Around the denominator. Okay? Be very careful using a calculator, especially when you don't have to. You don't need one for 2 times -3. I'm sorry. Okay? You should not need one for that. You shouldn't need one for 12 divided by 6 either. Okay? But as we get into these more complex formulas, more complex expressions, order of operations start to become a problem. Because your calculator does exactly what you tell it to do. And if you type this in without parentheses, you're telling it to give you 18 as an answer. Okay? Which is what you would get without the parentheses. So be careful. Be careful. Anyway, this is just the x value now. We're not even done. That's just the x. How do we go back and get the y? Nick, you plug it in. This is how you should plug it in. -3 times 2 squared. But I don't need the parentheses. I don't care. Put them in anyway. Right? They're not going to hurt anything.
7.
And if you did need them, if they were required, then you'd have them there anyway. So, -3 times 2 squared plus 12 times 2 minus 5. And just to make sure you can do it, everyone try it.
7.
7 is what, yeah, for those that don't have calculators, this test, if you're used to borrowing someone's, they're really not going to let you borrow it because you need it for pretty much every objective, save for 53. Okay, so bring your own. Okay, bring your own calculator. Bring a calculator that has a square button. Bring a calculator you know how to use. Bring your own calculator. So 2, 7 is the vertex. Let's plot that. That's going to be way up here. Okay, we know our parabola opens downward. So connecting our vertex to our y-intercept, we've got half of it there. I can draw curves better than I can draw
A straight line.
lines. Yeah.
Yeah,
My lines are curved anyway, so there you go.
You just try to draw a straight line.
So here's half of it, right? To find our, yeah? Okay. To find the other half now, Maddie.
I was just wondering how you got the dot right there.
This one?
Yeah.
That's where 2, 7 is.
Oh, I thought 2, 7 was lower.
X value of 2, Y value of 7.
Oh.
Okay.
Yeah.
Nathan?
You have to move 4 over.
So using our axis of symmetry, putting that imaginary vertical line, our symmetrical line, through the x value of our vertex, we look at our y-intercept and we say, how far away from the axis of symmetry is the y-intercept?
2.
So how far do we move on the other side?
2.
2.
4 from the dot.
And there's the other half. Okay? The order pair of that is what? 4, negative 5?
It's because 8 is negative.
There we have it.
If 8 is negative, then
This is really
if 8 is positive.
It's easy, as with anything, it's easy once you get it. Okay? If you haven't gotten it yet, that's okay. But ask questions. There are a lot of opportunities here, negative signs, order of operations in the calculator, things like that. If you don't got it yet, that's okay. But ask questions. Cool.
Do you think the Packers will make the playoffs?
Yes, Maddie. If you want,
No.
I'm not going to sign any for homework.
Thank you.
So if you
I'm
want to
gonna
practice
do all
one, go for it. We'll do it tomorrow.
I'm
What if
I-
all of it.
I did not say you could close your binders though. So
Yeah,
open them
guys.
up. Open them up.
One over is yourself.
Open them up.
Mine is opened up, sir.
Open up.
Professor.
Binders open.
Professor, sir. Mine is open.
All right, you may close your binders. No homework for tomorrow.
Professor,
No homework today.